Assalamualaikum. I'm Nurezzah Haziqah binti Rahiza and my group member Ali Akashah, Joshua Hiew Jun Wei, Mok Bin Hwa and Wong Qin Ung from Group 5. Today we want to present about element that we choose is uranium. Uranium is a chemical element with the symbol U and have atomic number 92. It is silvery gray metal in the actinide series of the periodic table. A uranium atom has 92 protons and 92 electrons, of which 6 are valence electrons. Uranium also has 142 neutrons, and the nuclear number for uranium is 234. Uranium is a weakly radioactive because all isotopes of uranium are unstable. Electron configuration for uranium is based upon the placement of uranium in the fourth column of the actinide series of F block in a periodic table. Therefore, the electron configuration for uranium must end as 5F4. So, the uranium electron configuration is Rn in the bracket 7s2 5f4. What type of element is uranium? Uranium is naturally radioactive. Its nucleus is unstable, so the element is in a constant state of decay, seeking a more stable arrangement. In fact, uranium was the element that made the discovery of radioactivity possible. In 1897, French physicist Henri Becquerel left some uranium salt on the photographic plate as a part of some research on how light influenced this salt. To his surprise, the plate folded up, indicating some sort of emission from the uranium salt.
Now, I'm going to talk about the isotopes of uranium. First, natural uranium consists of 3 isotopes which are all radioactive. But before I talk about the isotopes, uranium has an atomic number of 92, an atomic mass of 238.03 grams per mole, and a density of 18.95 grams per centimeter cube. These are the 3 isotopes of uranium that exist on Earth: uranium-238, uranium-235, and uranium-234. First, uranium-238 has an abundance of 99.28%, which makes it the most stable isotope among the 3. It has a half-life of 4.468 times 10 to the power of 9 years, which is roughly the age of Earth. Second, uranium-235 has an abundance of 0.71%. It has a half-life of 7.13 times 10 to the power of 8 years. Lastly, uranium-234 has an abundance of 0.0054%. It has a half-life of 2.48 times 10 to the power of 5 years. Now, I will show you some pictures of isotopes of uranium that can be found on Earth. Pictures can be found for uranium-238 and uranium-235. However, uranium-234 cannot be found as it is too rare and there is a too little abundance of it on Earth. Now, we are going to talk about some physical properties of uranium. First, uranium is a hard, dense, malleable, silver-white radioactive metal. It has a melting point of 1132 degrees Celsius and a boiling point of 3818 degrees Celsius. Uranium is radioactive and usually emits alpha particles, but it has also been seen emitting beta and gamma particles as well. Uranium is considered a good conductor, but it has poor conductivity when compared to another metal such as iron, but it has less than half conductivity compared to it.
Hello, my name is Wong Qin Ung. Today I would like to talk about the chemical properties of uranium. Uranium method can react with almost all non-metallic elements and their compound with reactivity increasing with temperature. This is the example of the non-metallic element, which are oxygen, chlorine, sulfur, fluorine, phosphorus, and bromine. Now let us talk about the chemical form of uranium. The first one is uranium oxide. The most common form of uranium oxides are triuranium octoxide and uranium dioxide. But triuranium octoxide is the most stable form of uranium as is the form found in nature. This is the image of triuranium octoxide and color of it is yellow. Then the second image is the uranium dioxide which is black. Now the second one is uranium hexafluoride, which is a chemical form of uranium that is used during the uranium enrichment process. Within a reasonable range of temperature and pressure, it can be a solid, liquid, or gas. Solid uranium hexafluoride is white, dense crystalline material that resembles rock salt. Now this is the image of it. The last one, which is uranium tetrafluoride. Uranium tetrafluoride is a solid composed of agglomerating particles with a texture similar to baking soda. It is non-volatile, non-hygroscopic, but only slightly soluble in water. Uranium tetrafluoride is the most used nuclear material for producing metallic uranium by reduction with calcium and magnesium. Then this is the image of it, and the color of it is green. Then that's all for me. Thank you.
Hi and good afternoon everyone. I'm Joshua Hiew Jun Wei from section 34 and I'm from group 5 for assignment 2. So for my part, I will explain the uses and application of uranium. So in this PowerPoint, I will explain what is uranium, the uses and application of uranium, and the nuclear fission and the chain reaction of uranium. So first, what is uranium? Uranium is a metallic silver gray element that is a member of the arsenic series. It is the principal fuel for nuclear reactors, but it also used in the manufacture of nuclear weapons. Next, the uses and application of uranium. Uranium fuel used in the nuclear reactors is enriched with uranium-235. The chain reaction is carefully controlled using neutron-absorbing materials. The heat generated by the fuel is used to create steam, to turn turbines, and generate electrical power for nuclear submarines, nuclear aircraft carriers, and in nuclear weapons. Secondly, uranium is also used in atomic bombs. Atomic bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosions. These bombs are in contrast to hydrogen bombs, which use both fission and fusion to power their greater explosive potential. Thirdly, the depleted uranium that mostly contain uranium-238 can be used for radiation shielding or as projectiles in armor-piercing weapons. Next, the third, nuclear fission of uranium. So what is nuclear fission? Nuclear fission is a process by which the nucleus of an atom is actually split into two or more smaller nuclei, known as fission products. The fission of heavy elements is an exothermic reaction, and huge amounts of energy are released in the process. In nuclear fission, an unstable atom split into two or more smaller pieces that are more stable and releases energy in the process. The fission process also releases extra neutrons, which can then split additional atoms, resulting in a chain reaction that releases a lot of energy. There are also ways to modulate the chain reaction by soaking up the neutrons. Next, the fourth, the chain reaction of uranium. When a large fissile atomic nucleus such as uranium-235 or plutonium-239 absorb the neutron, it may undergo nuclear fission. The nucleus split into two or more lighter nuclei, releasing kinetic energy, gamma radiation, and free neutrons. A portion of these neutrons may later be absorbed by other fissile atoms and trigger further fission events, which release more neutrons and so on. This is known as the nuclear chain reaction. Next, the chain reaction can be controlled using neutron poisons and neutron moderators to change the portion of neutrons that can cause more fission. A neutron moderator works to reduce a newly produced neutron's kinetic energy from several MeV to thermal energies of less than 1 eV, making them more likely to induce further fissions. Third, the nuclear reactors generally have automatic and manual systems to shut the fission reaction down if unsafe conditions are detected. The amount and nature of neutrons moderation affects reactor controllability and safety. Since moderators both slow and absorb neutrons, there is an optimal amount of moderator to include in a given geometry of reactor core. I hope you guys understand what I'm talking about. So, thank you and goodbye.
Hi, my name is Akashah bin Muhammad Rashidan, and I will talk about disadvantages of uranium. Firstly, radiation. Okay, for your information, uranium is commonly used as nuclear fuel in nuclear industry lah. So, but the uranium used is uranium-235. It is the isotope of uranium, and U-235 is naturally radioactive. It is a very unstable element. So, what is the impact if we are exposed to the uranium radioactive or uranium radiation? So, firstly, you can the risk you can have a lung cancer, kidney damage, bone cancer and liver cancer. How come the radiation can make us have a cancer, right? So the radiation will mutate our body cell, and the mutated body cell will become a cancer cell. Okay, so the next disadvantages of uranium is mutation. So what is mutation? Is mutation like X-Men, Wolverine? The answer is no. So mutation in real life is when a DNA gene is damaged or changed in such a way as to alter the genetic message carried by that gene. So simply, it means that mutation will make us have defects lah, like cancer and many more. So so now I will talk about the mutation that happens to baby. So firstly, they have birth defects. Birth defects is like they not complete lah, not perfect condition, like they don't have nose or large heads. They like what we call that in Malaysia, PPKI, like that, something like that. So when they have birth defects, it leads to infant death. This is because the defects is very significant to the baby lifestyle lah. So for example, they have the difficulty to breathe, to eat. Okay, so the infant death leads to low mortality rate. So many of the mutated babies don't survive the condition lah. So that's it for mutation. And lastly, we have the effects of uranium in war. So how does what is the role of uranium in war? So uranium is commonly used in creating bombs lah. For example, they use uranium in nuclear bomb, and we all know that the Nagasaki and Hiroshima event, right? So that is the example of nuclear bomb lah that can be used with uranium. So what is the effect of war? Right? So the effect is high casualties. So the explosion affects a large area, right? So the people within the range of explosion will obviously die from the explosion, right? So high casualties, and next is destroyed infrastructure and dying flora and fauna. Okay, so the bomb is created by uranium, right? Uranium is a radioactive element. So when the explosion happen, the area that affects will have a radiation effects. Okay, and the area will become radioactive. So this will be a long-term effect. This is because the radiation have a high long half-life. So we call it Malay separuh hayat. Okay, so they have a long half-life. For example, they can stay there for 100 years, 1,000 years. So it's not easy to get rid of the radiation effect. It will take a long time. So that's the disadvantage of uranium. So that's all from me. Thank you.